Hello and welcome back to the solution videos for the Marquette ACM UPE Programming Competition 2017. We're on to question 7 now, Roll for Initiative. This question tasks students to write a program to figure out if certain dice combinations are possible for our letter dice setup. So the way that this setup works is that you have 5 dice. Each of them is 6-sided but has 6 different letters on each side. Not all the letters of the alphabet have to be used. It's just 6 random letters on all the different sides of the dice. And then you're given a word as well as the sides of the dice. And you need to determine if it's possible to roll this word just by rolling all 5 of the dice. So for example, if we look at this first sample input right here, so our first 5 dice are given here. So there's one dice here that has an A, a B, a G, an R, and a T, and a Y on its 6 different sides. The second dice has E, G, K, O, W, and X. Third die, fourth die, fifth die. And then we're trying to test whether or not we can roll great. So you might, one way to do this might just be to go through all the letters. So or go through all the dice. So for example, if we look at our first die, we've got a G on there, so we could roll a G for the first die. And then we look at the second one, and there isn't an R on here. So we aren't going to be able to roll that R, but there is an R on the first dice. So maybe we roll the G on the second one, and an R on the first one instead. So then we keep going. So I see an E over here on the fourth dice, so I can grab the E from there. There's an A here on the third dice, so I can just grab an A from there, and then a T on the fifth dice. So I've found a solution where I've put the G on the second, the R on the first, the E on the fourth, the A on the third, and then the T on the fifth. That's a way that you can roll all the word great out of these 5 dice. Whereas with the second example, no matter how you try to arrange it, there's no way to roll the word tiger on these dice. So we'll be writing our code in this skeleton right here. So we'll get the 5 dice as a string with 6 letters being a part of that string, and then a word that we're trying to roll. And then we need to output true or false whether or not we are able to roll the word with these 5 dice. So let's get to it. Okay, so the first thing that we're going to want to do is convert all these dice into something that we can iterate through. Our solution is going to basically just be a brute force search. We're going to try every single combination that we can of these 5 dice and see if any of them line up with the word that we're trying to roll. So this might be slow, but we can always test that afterwards and try to make it more efficient if it is too slow for our competition. So the easiest way to do this is to split up each of these dice into character arrays, char arrays. And you can simply do that with a string just by doing toChar array. I need to make these a different name though. So D1 will be die1.toChar array, just like that. And then same for the other ones. I'll just copy paste for the rest. So 3, 4, 5, and 6. 3, 4, 5, and 6. So now we have an array for each dice containing the different characters on that dice. Then we can use for loops to go through them all. Sorry, we only have 5 dice. So then let's set up those for loops. So for the first one in die 1, for each one on die 1 at D1, and then for each one on D2, and for each one on D3, and for each letter on D4, and for each letter on D5. So these loops will loop through all of the combinations and all of the letters. So now the way that we can check whether or not we can arrange these dice in some order to spell our word is to first put them in a char array of their own. So we'll call this rolled, for example. So we'll have 1, 2, 3, 4, and 5 all be in this array. And then we'll go through each of them and attempt to remove them from Word, essentially. So we're going to make a copy of Word really quick. We'll call it test Word. So we'll start off as Word, but we're going to try to pull each of the characters out of test Word. And if we can successfully do that each time and then end up with the empty string at the very end, then we've found a way to spell out our word. So that's going to look a little bit like this. We can use index of to find the first spot within Word, the test word, where our character occurs. So we can say an index variable equals test word dot index of the current character that we're looking at. And if this is -1, that means that it wasn't found in our test word, meaning that we have a dice that we couldn't use. We couldn't pull this letter out of the word. In which case, we just need to continue on through the to the next letter. We need to go through the next letter combinations. So the way that we can do this is we can just set a flag here. So we'll call this could spell. So we'll assume at the start of this for loop that we can spell the word, but only if we ever find that we can't pull out one of the letters will we set this to false. And if that's the case, we can break out of this loop because we don't need to test any of the other letters. We've found that we can't spell it. Otherwise, we should actually go and pull it out of the word. So we'll say that test word is equal to the part before the current character. So from the start of the string up through, but not including our character, concatenated with the part after the letter that we're currently looking at. So start at the string +1 all the way to the end of the word. That's how you can spell that out. Alright, so at the end of this for loop, we will have determined whether or not we could spell the word. If we could spell it, then great, we found a way already, so we can just return true right off the bat. Otherwise, we just need to continue on. So we don't need any code for that. We can just follow through and continue on with the for loop. If by the end of this we haven't found a way to spell out our word, we can just return false. We won't need this variable at the top. It means that we've tried all of the solutions, but never was the could spell variable true, so we could never ever spell our word with any combination of the letters. Alright, so let's test this out. So let's run our solution. We'll just throw 10 test cases in there. Alright, so first off, one on each line, we type the string for each of the dice. So the first dice has A, B, G, R, T, Y on it. Second one is E, G, K, O, W, X, A, B, V, C, X, A, P, O, Y, E, A, T, E, I, T, Y, T, J. And then the word that we're trying to spell first off is great, and we are able to spell it. That was the correct example where we could go G on 2, R on 1, E on 4, A on 3, and T on 5. However, if we do the same set of dice, but try to spell tiger, we find that we aren't able to spell it. So there we go. That's how we do question 7.